Phase 1 and Air Data Solution. So today I have the privilege to be joined with two guest speakers. So Don Cummins, President from Air Data Solution, and also Kevin Graville from Phase 1 Industrial, which is a system sales manager in the US. My name is Simon Grandin, and I'm the photogrammetry specialist here at SimActive. So today, the topic of our online training session will be how to use metric cameras for accurate mapping. So the presentation will go as Phase 1 will start with their presentation of their system. Then we'll talk about how you can process Phase 1 images in Correlator 3D. And we will finish this presentation with a real case scenario from Don Cummins, which is a Phase 1 camera owners and also SimActive users, and how we can manage both hardware and software in real world scenarios. So let's start with Kevin from Phase 1. So Kevin, here's the presentation.
Thank you, Simon. Once again, welcome everyone. My name is Kevin Graville. I'm the System Sales Manager for the Americas. This means that I have the honor of working with companies interested in utilizing our lineup of metrically calibrated medium and large format digital cameras as a complete system. However, today I plan to share a bit more about why I feel Phase 1 cameras are the best cameras for any aerial survey mission. Phase 1 is a leading provider of digital imaging solutions. We provide ultra high resolution cameras and highly productive software solutions to enable our customers with better and more productive imaging workflows. Founded in 1993, our headquarters is in Denmark, and today we have partners and employees in over 50 countries around the world. Phase 1 thrives on innovation and pushing the boundary on what is possible. Whether this is collecting amazing high-resolution imagery for a digital twin of a city with our new 880 megapixel nadir and oblique camera system, or documenting our cultural heritage in a museum archive. Phase 1 seeks to provide the highest quality imagery possible. Here in North America, our sales and support is located in Broomfield, Colorado, right on the Rocky Mountain Metro Airport. Now, to keep us on schedule, I'm just going to briefly go through some of the cameras that Phase 1 has. First, we have our IXM series of cameras. This system is very versatile and are light enough to be placed on a large number of UAV platforms, and can also be integrated into manned platform solutions as well. We just released our new P3 payload for integration into even more UAV platforms. A nice feature with this new integration is the fact that we have incorporated a rangefinder for even better imagery for inspection applications. You can choose from either a 50 megapixel or 100 megapixel camera, and there are 4 specifically designed RSM lenses that are machined at our factory in Japan. A unique feature, I should say, of this RSM lens is the ability to remote focus the lens. This allows the user to adjust focus on target while in flight. We next have our IXM RS camera lineup with 100 and 150 megapixel options. These cameras can be paired with an amazing number of lenses to create your ideal match for image resolution, for area coverage, all from a variety of different flight altitudes. Due to the compact and rugged design, these cameras can be easily integrated into other sensors to add imagery collection efficiencies on your current aerial survey missions. Phase 1 has optimized our cameras into a variety of standard aerial solutions. The rugged compact design of Phase 1 systems allows you to take advantage of smaller, more efficient aircraft due to the light weight, or maximize your collection speed of larger aircraft with our extremely fast capture rate of 2 frames per second. Our systems are customizable and not limited to one single solution. One of the new advancements in the central hub of the system, the IX controller, is the integration of the Applanix GNSS system inside the IX controller. This reduces the number of external connections and improves the efficiencies of the system. Not only is this a hardware solution, but Phase 1 also offers our IX suite of software to cover everything from mission planning to mission execution and image processing. The latest system I'm going to briefly touch on is our new 880 megapixel nadir and oblique camera system. This system incorporates our 280 megapixel camera in the nadir, as well as 450 megapixel cameras with a 150 millimeter lens in oblique directions. The system will be a game changer, and I look to share more on this over the next couple of weeks. All right, I want to dive now into some of the key features that allow Phase 1 cameras to provide superior image quality and accuracy. For accurate photogrammetric measurements, Phase 1 offers our metric calibration. This maps the distortion of your chosen lens to the accuracy to solve the photogrammetric equation. This is done at one of our calibration labs, and we even do test flights of some of our larger systems, such as the 280 megapixel camera, to ensure the highest quality of our calibrations before delivery to the customer. Here is an example of one of the Phase 1 280 megapixel 4-band cameras that was recently delivered to a client, flown over our test field. The flight test was collected at a 4.8 centimeter GSD, and it resulted in an RMS error of 0.8 centimeter XY and 1.3 centimeter in Z. We have over 34 GCPs surveyed on this site, and a number of them are used as checkpoints as well as ground control points to make this calculation. While many camera manufacturers utilize a CMOS sensor, Phase 1 cameras uses the latest backside illuminated sensor. This sensor provides the highest dynamic range while allowing for collection of imagery even if conditions are not ideal for photography. Here is a great example. At first glance, the image on the left seems to have some very dark shadows next to the buildings. However, when adjusted, you can resolve the details in those shadow areas. Another key feature of Phase 1 IXM RS cameras is our reliant shutter. This shutter is capable of speeds up to 1/2500th of a second. The shutter is warranted to over 500,000 activations, and as previously mentioned, is capable of collection rates up to 2 images per second. This fast shutter allows for high overlap at high resolution and high speeds. Of course, with high speeds comes the concern for image blur. The blur control technique of the Phase 1 camera also capitalizes on our high shutter rate. This results in crisp, high-quality imagery. One of the best ways I can think of to show you this are some examples of some amazing imagery. Here we have an example on the right side of a helicopter in flight. You can definitely see that the ground beneath the helicopter is definitely got some wind, but the blades of the helicopter look pretty still. Here's a fun photo showing an aircraft in flight. And of course, a 1.5 or 15 millimeter GSD, 1,000 feet above the ground at 250 knots, taken with one of our 190 megapixel cameras. The last thing I want to talk on that to help optimize your imagery would be mission planning. For this, Phase 1 offers our IX Plan software. This powerful software quickly assists in preparing the optimal flight plan to achieve the needed results from your aerial survey missions. Phase 1 has the camera solutions for your projects, whether it's manned or unmanned, just like SimActive has the next steps covered. Thank you for your listening, and look forward to hearing about SimActive software and what Don's been doing with our cameras and software.
Thank you, Kevin. So now on the SimActive side, I will be presenting the workflow of processing phase 1 data from start to bottom. So about SimActive, briefly, so SimActive is a leading developer of photogrammetry software since 2003. Our software was first developed for large frame sensors, and throughout the years we've adapted our solution to smaller sensors as the drones. As of today, we have thousands of users in more than 100 countries. And we're also continually innovating with our Correlator 3D product, which has around 4 major releases per year, and also minor releases for continuing innovation for photogrammetry processing. So Correlator 3D as a universal workflow for metric cameras. And also we support different types of sensors. So as of the drones, we're compatible with any UAV platforms, any types of sensors and cameras, from the RGB camera to the multispectral, or even to the thermal cameras. Also with a wide range of aircraft cameras as well that can be integrated with SimActive. And finally, we can also process satellite data, large commercial satellites within Correlator 3D. So now let's talk about the optimal workflow for phase 1 camera. So the workflow is pretty much a standard photogrammetric workflow. So once your project, you have flown your mission, you have captured the images, and then you're ready to process, you'll be able to create your project with or without ground control points, depending on your requirement for your project. And then you will jump into the software, and basically the software is divided into 3 big modules. So the first module, it's where all the accuracy is getting reached for your project, which is the AT module. It's at this point where we will extract tie points between the images. You will be able to mark your ground control points, and then also your checkpoints if you want to, and then you can refine all those inputs and find a final solution that will fit your accuracy measurements for the processing of your mapping products, such as DSM, DTM, orthos, even more mosaic or 3D models. So the second module that we have is basically where we extract elevation data from the input images, which is basically the surface model. From this surface model, or even point cloud, we can derive an automatic terrain model. And depending on the model you want to use, we can provide orthophotos and orthomosaics for mapping purposes. Optionally, we have other add-ons, such as 3D modeling if you have oblique imagery and nadir imagery. We also have contours generation, volumetric calculation. So all tools that can be run with output from your mapping product derived from phase 1 cameras. So first, let's talk about the first module, which is the aerial triangulation. I would say the aerial triangulation is the most important part of your project, because everything, all the accuracy resides into the AT solution. So the first thing is how to perform the aerial triangulation. So as I said before, it's in 2 steps. So the first step is extract tie points between all the images. So the software will find common features between different flight lines and different images to have a nice block of images that will be able to tie on the ground control points. The numbers of tie points that we found is highly affected by the overlap and the size of the sensor that we have. So you want to have a good redundancy to have a nice block of images for generating your mapping product. Once the tie points are extracted and you have a nice spider webs of link between all your images, you can then import your ground control points and your checkpoints. So basically, the ground control points will help to tie the photogrammetric block to real world coordinates. Optionally, if you really want to validate the overall accuracy of your project, you can also add checkpoints, which are going to be compared to the final solution that we have found and will really give you the truth accuracy of your project. When you want to check this accuracy, well, you will need to perform a bundle adjustment. So the bundle adjustment is where we typically refine sometimes the sensor the sensor orientation and also the image orientation, and we tied all this information to the ground control points. Depending on the sensor that you have from phase one, let's say of the 280 megapixel, well, all the metric information from the cameras is already provided by phase one, so you can directly take the input of their calibration process and digest it into Correlator 3D. So it gives you one less uncertainty to figure out during the bundle adjustment process. Let's say once the bundle adjustment is performed, you can then interpret your quality report, which will give you the overall accuracy of your project. Now let's see how it looks with a phase one project. So here, as we have an example, so it was a project that was flown with a 150 megapixel camera. We were around 60 images. So we basically give an overview of the relative accuracy of the project. We then also give the residual over the ground control points. And if we compare this overall solution to the checkpoints, well, we can see that we have a pretty nice accuracy for our photogrammetric solution. Also, you can review the bundle adjustment parameters that was done for your project, and we also give a wide range of statistics based on the relative accuracy, the absolute accuracy, the overall image adjustment to the ground control points with or without the bore sight if it was performed. Also, we give some sensors information, and mostly the important part is the overall accuracy on your ground control points and on your checkpoints. So you can really see, you can really derive the final accuracy of your project. So once you're comfortable with the AT solution, I would say that the rest of the mapping product generation should go pretty much smoothly since you have a good solution and you're sure that your accuracy meets your deliverables. So once the AT is done, it's at this point where we can generate all the elevation data. So basically, the way that the software works is we extract raster-based surface and terrain models for mapping purposes. So we can derive GeoTIFF's surface model and terrain model. So by default, when the users want to derive a surface model from phase one images, we propose a ground simple distance of 5 times, a resolution of 5 times the ground simple distance. However, with such highly quality product, you can lower this resolution to 3 times the ground simple distance. So it means that if you have, let's say, you have a resolution of a GSD of 1 centimeters, well, you can probably generate a surface model at 3 centimeters roughly, and you should have pretty good results. Also, the resolution that you want really needs to be derived from your project requirements. If it's not necessarily necessarily need a high resolution DSM, well, you can always lower the resolution and you'll have faster processing. From this surface model, we can also derive point clouds, point cloud data, and that will be stored as a LAS file, and also it can be colorized with the input imagery. So at the end of the workflow, you will have the LAS with the RGB information. From the DSM, we can also derive terrain models. So we have an algorithm that removes not terrain-related elements such as trees, buildings, that we can derive out from your surface model. Optionally, for certain situation, let's say you have a bridge or you have an overpass in your project, you can always use exclusion areas if you really want to refine the overall terrain extraction from your surface model. And then finally, well, once your elevation data is already produced and you're happy with it, you have compared it to the ground control points and everything fits, well, you can derive orthomosaics and orthophotos. So basically, the orthomosaics process is in two steps. The first step is basically where we derive individual orthophotos from each images. So all the input image will have an orthorectified images. Then, with all of those orthorectified images, we'll be able to derive a seamless mosaic where you will be able to have export as a GeoTIFF file. Those orthomosaics can be tiled at the end if you want to have smaller size. Let's say you're planning a large project. Sometimes it can be challenging managing a large mosaics. So it can be good to break down your project into smaller sections. One other element that is pretty useful with the software is you can edit all of your seam lines to enhance the final quality of your mosaic. And especially for phase 1 users, with our latest version, we have added an options where you can integrate their surface model in your mosaic creation. So when the seam lines are getting created, well, we use the elevation data to really reduce the area where we can cross seam lines. So we would cross seam lines on areas where there's no parallax, such as ground. So it at the end really reduce the amount of editing time that the users need to perform on this project. Finally, if you want to assess the overall quality of the data, you can then pan into your mosaic, and then you can pan into the mosaic, make sure that the ground control points fits your final mosaic. You can also assess the radiometric quality of your cameras if you want to play with the histogram color. You can always stretch it, or depending on what you need. You can also use external sources for validation. So let's say you want to validate the accuracy of your digital terrain model or surface model from, let's say, a shapefile that contains 3D coordinates. You can import this 3D coordinate shapefile and then compare it to the final DSM, and then you will be able to see if the overall solution is accurate and meets your requirements. And then finally, as unique benefits from SimActive, well, we have a solution which is an unmatched processing speed. We really relies a lot on the GPU and a lot on SSD drives, so you can crunch a big amount of data in a short amount of time. We also have no training is required because we have an automated solution with a one-click button, but also we offer the full range of of module, and the users can really set his own parameters for each of the steps. We can manage project with unlimited numbers of megapixel on the standard licenses, and the software can be integrated into the cloud and can be also used in a command prompt interface, and all the processing can be scripted out and launched directly in the command prompt. Finally, well, we have different licenses options. So we offer monthly, yearly, or permanent licenses. We have a UAV, medium format, or full format license. We have node lock or floating license. And then if you want to get started with Correlator 3D, well, you can always download a free trial from our website and test it out on your own data sets to see what you can get from your phase one data. So now I will let the microphone to Don, which will talk about how you can integrate phase one data with SimActive into real world scenarios. So now, Don, it's your turn.
All right. Thank you very much. It's a pleasure to be here today. I appreciate the opportunity to share with you all and to join in this presentation, talking about a little bit of what we do, how we utilize the phase one cameras and SimActive correlator for processing. These have been instrumental in our success over the years as we have grown and tackled more challenging projects, larger projects. Both phase one and SimActive have been up to the task to keep us on schedule and help us to continue to deliver the results that our clients expect. So I'm going to begin with just a little bit of an overview of Air Data Solutions, who we are, what we do, and then we'll jump into a couple of projects that we've done that I feel showcase the capabilities, and we'll follow up with time for any questions. So again, my name is Don Cummins. I'm the president of Air Data Solutions. Air Data Solutions was formed in 2015 as an aerial data collection company. We also provide data collection on the water with bathymetry and sonar, and we do land-based projects as well. And we actually utilize the cameras and sometimes the processing for non-traditional methods, land and water-based as well. I won't get too much into that now, but like Kevin said earlier, we're always trying to push the limits of what's possible and what's accepted. Our mission statement, who we are, like I said, aerial, terrestrial, underwater data capture. Some of the reasons that we are respected in this space is we not only utilize the best equipment, the highest quality equipment, but we also have the subject matter experts, the experience from our staff and our team who understand the industries that we serve and work in. So we try to build all of our solutions around the experience that our team has, rather than taking a product or a camera sensor and or a drone and trying to plug it into a hole. We start first with the industry knowledge, and then we build that program around those people. Our personnel, we have 10 staff pilots, manned and unmanned pilots that work with us on staff. We have A&P mechanics, fabricators, CAD techs, photogrammetry, LiDAR techs, and boat captains. So we have a lot of talent that spans many industries, and we basically have the ability to pretty much take on any kind of data collection project. If we haven't done it, we're not afraid to say no or yes. We'll jump in and try to figure it out. And doing that, it's critical to have a team behind us like phase one and SimActive brings, so that when we are trying something new, they're always very responsive and very helpful in helping us work through some of those new challenges. Our project map, this is some of the locations that we've worked in the past year. We do projects coast to coast. Our base of operations is in Louisiana and Texas. So you can see that the majority of our work is in the south and southeast. But with our aircraft, with our drones, we travel pretty much anywhere where the work is. Our aircraft home bases, our owned aircraft are at the yellow dots. So we have hangars and offices in Texas, Louisiana, and Pennsylvania. And then we have contractors who work with us on a daily basis based around Texas, Arkansas, Mississippi, and Nebraska. So we're centrally positioned to be able to deploy pretty much anywhere quickly. And as you'll see in the slides coming up, that's a fundamental part of our service that we provide to our customers, is getting places fast and getting the job done quick. Some of our accomplishments real quick. We are a hub zone business. So we operate out of an underutilized area, which allows us to help fill that specific requirement on federal and state contracts. We've been featured in several magazines and are proud of the Ag Researcher of the Year and Ag Aviation Magazine accomplishments that we've received, because our background and where we began was in the agriculture industry. So that's still a fundamental part of what we do, but we also have branched out into oil and gas, power infrastructure, construction, and disaster response. So to move on into some of our equipment, to start with the aerial platforms that we utilize, they range from twin aircraft, small Cessna single engine aircraft, and helicopters. And our drone platforms range from VTOL, vertical takeoff and landing drones, to large heavy lift rotorcraft, to small drones used primarily for asset inspection. The sensors, we currently operate 5 different phase 1 cameras. These are all the 100 megapixel sensors. They have 2 of them have 90 millimeter lenses, 2 have 50 millimeter lenses, and one, the IXM 100, has an 80 millimeter lens. So it gives us the ability to specify our ground sampling distance, our flight altitude based on the weather, the aircraft available, and basically the mission profile, so that we can fly higher or lower and get in position at the most optimal location. We also operate like a terrain mapper and collecting LiDAR. And then for special missions, we use OGI cameras, thermal cameras, hyperspectral, and video. Our markets are primarily on-demand imagery and LiDAR. So while we do have some contract work that's recurring, most of our projects is one-off, and it's typically a quick turn on-demand type of service. So as I mentioned before, we started in the agriculture field, very time-sensitive industry, very dependent on weather, and that's kind of been our niche. And the market is understanding the importance of getting there quick, being dependable, and getting the job done, often in a very limited scope of time that we have the weather windows or the right scheduling dates and aircraft availability. To build on that, we do a good bit of disaster mapping, response to natural disasters like hurricanes, fires, tornadoes, hail. Also very time-sensitive missions. The airplane plays a critical role in getting to the location before ground crews can get there, often before emergency workers and response can get there, and we're able to give them an assessment and a picture of what's going on and where the response needs to focus. And kind of on the other end of the spectrum from the quick turn, rapid delivery work is research and grant work, engineering and survey work, and then leak detection and pipeline patrol. Some of our challenges is logistics. Working coast to coast means that we have a lot of ground to cover, often a short time to get there. And just managing where those aircraft and assets are, where the crews are, and what's available, it can get complex. Demanding timelines, as I mentioned before, the weather always plays havoc on all of our best plans. Logistics, crews, and then once you get there and get on station, the next challenge is getting the data transferred, processed, and delivered. So we'll talk a little bit more about that in just a minute. So those are our challenges. Our solutions. Phase 1 sensors, they've proven to be extremely reliable. They're high quality and efficient. We know that if we can get in the air, these will work for us. And we have very little downtime related to the operation of the sensors. Most of the time, if there is any kind of an issue, it can be resolved in flight. And they've just proven to be an extremely reliable sensor to operate. The data processing side, the same three factors are extremely critical to us as well: reliability, quality, and efficient and fast. And SimActive has proven to us to be the fastest image processing software available. We've tested a lot of them, and the speed that we get with the SimActive software is truly second to none. On a very small scale, we can I've demonstrated processing 8 to 10 100 megapixel phase 1 images in literally less than 2 minutes, start to finish, and it's very impressive to see the software work. On a very large scale, we've processed thousands of images, and sometimes that can be accomplished within a day, sometimes hours, depending on the level of accuracy and the amount of quality checks and adjustments that need to be done in the process. So the speed and the quality and confidence that we know that the results will be good every time is very important to us. And over the years, we've also seen a lot of feedback from our clients who either request processing from SimActive Correlator, they request imagery from the phase 1 cameras versus some of the other cameras, or they just say, we know that something's different about what you use, whatever it is, that's what we want. We've actually had requests not to use other software because of quality concerns. So it's been reassuring to us to get that kind of feedback from our clients that they're very happy with the quality that we're delivering. Now to dive into a couple of the recent projects that we've been working on. We'll start with one that I'm calling the Atlantic to the Pacific project. This was a client requested us to collect 1-inch spatial resolution on 35 different sites along the coast. About half of those sites were along the Atlantic coast from North Carolina up to Maine, and the other half were on the west coast from Southern California up to Washington. And originally this was slated to be a drone job, but due to the number of sites, the location of the sites, and the complexity of the airspace, they reached out to us to see if we had any good options. So we were able to deploy a system with a 90mm lens on a small Cessna aircraft that could achieve that 1-inch spatial resolution and still collect, process, and deliver that data in a time frame that was faster than what the client expected. This was done beginning late last fall and finished up early this year. They required no snow, leaf-off conditions, and it was completely flown, collected, delivered within about 2 months. The workflow, we spent about 20 flight days collecting the imagery, around 90 hours. The 1-inch spatial resolution on all the sites. The project setup was 70/70 side lap and front lap, approximately 10,000 images, resulting in about 10 terabytes of data. The processing time on this was about 1 to 2. We did not use survey ground control, but we did use permanent features to tie the imagery to, which was something that helped keep the cost down and without overkilling the project standards by having to go in and set control for all these sites. The accuracy requirement was not that high, so we're able to do it quicker and more efficiently by just using permanent features for control. And the deliverable was orthomosaics and tiled TIFFs, and it was delivered on schedule, ahead of schedule and within budget. The client said that they were very pleased. They had used drone imagery in the past, and when they tied the imagery or were on the ground using the imagery for some of their work, they said they could see sometimes up to 20 feet of difference where the imagery said they should be and where the actual features were. So they said it was very easy to work with the results that we provided them, and they're very pleased with how it turned out. Another very interesting project that has spanned the past 6 months or so. It's an unfortunate project because of all of the fire damage that was caused last year on the West Coast. But it's also somewhat satisfying to see how the imagery and how these data products can be used to help in the reclamation and help in the planning to help mitigate future disasters like this. So last fall, this began with capturing about 20 different sites where the wildfires had burned. All of this imagery was collected at 3-inch spatial resolution with manned aircraft. We deployed 3 aircraft to the West Coast, and we flew about 1.5 million acres of land after, or in some cases, actually during, while the fire was still burning. And this spring, we came back and mapped about 165,000 acres of that. Also 3-inch resolution imagery included LiDAR, and we have been using that to do assessment for reclamation, damage assessment, and developing models that will help mitigate the risk of landslides and help understand what it has done to the countryside. On average, this was about 55 flight days, 250 flight hours. We used Cessna 206s and 182s. We did collect 4-band imagery on the majority of this, and we collected it on all of the post-fire reclamation work so that we could do vegetation assessment as well. 80,000 images, 45 terabytes of data. And the important part to this mission was the speed of delivery. Accuracy was not critical, but getting an assessment from the imagery was. So our average delivery time from collection to the client receiving the orthomosaics was 4 days. This also included data transfer time. This was from the time that the airplane finished on station until the final product was delivered. So this would not have been possible without the speed of the SimActive correlator processing engines. It would not have been possible without having the reliable equipment that could operate in these extreme conditions on station in these areas. And then kind of the other spectrum of work would be the more tightly controlled accuracy projects that we do with survey and engineering firms. This is an example of a road development project in Texas where we collected about 2 centimeter spatial resolution imagery and used ground survey control. The absolute accuracy was a little over 1 inch, and turnaround time about 3 days. So this was used for alignment sheets and for pre-construction survey on a road lane widening project. So the accuracy that the phase 1 camera paired to the IMU, Planix IMU systems, is very good. And then using the SimActive processing, the AT, and what Simone had mentioned, and quality checks and assurance has been demonstrated to us over and over that this process is excellent for creating high accuracy survey quality work. This was also collected out of a manned aircraft. That is it for us. I'll be happy to answer any questions, and really appreciate the opportunity to share this and to work with these great partners.
Thank you, Don. So to finish off this presentation, I will answer, or we will answer a few of those questions that we got during this presentation. So I will be able to present or to present some features that were asked as questions. So first of all, the first questions that we have is concerning the bundle adjustment parameters. So can the X, Y, Z values be constrained and let only the omega phi kappa unconstrained? So when you process data with SimActive, well, when you run the bundle adjustment, you have the full control on the adjustment. So on the EO's adjustment, if you leave it to constraints, you can constrain only some of those parameters that you want to. So if you only want to optimize the omega phi kappa because you're sure that the XYZ are pretty much accurate, it can all be derived from this setting. The uncertainty value is regarding the projection unit you're using. So if you're working, let's say, in UTM, the uncertainty will be in meters. If we're working in state plane, let's say, well, the uncertainty will be in feet. Second question that we have is, are we able to provide stats indicating the accuracy of the DSMs relative to the AT solution? Let's say comparing the tie point Z values with the DSM. So yes, we're able to provide or to compare the tie points, the tie point coordinates with the derived DSM. It requires a few modifications, but it can easily be done. So when you perform the bundle adjustment, basically we derive a file with all the tie points coordinates. So you can derive the shape file with those coordinates, and can be used in accordance with the DEM inspection tools. So we'll be able to derive the bias, the RMSE, the standard deviation from the elevation of the tie points and the final surface model. So that's one way to compare the tie points and the final DSM. How far down the processing chain we can go with the 880 megapixels phase 1 system? So basically, we can manage their system, so the nadir and the oblique imagery, for mapping purposes and also for 3D modeling. So if you want to generate 3D models, you can derive an AT with the all the images, derived a surface model, and then from this surface model, you can texturize this mesh, this model as a mesh with the input images. So the oblique and the nadir imagery. So at the end, you will be able to export your 3D model as an OBJ file, So it can all be integrated within directly within SimActive. Also, one questions for Kevin, which is just trying to find it out, is does phase one as rolling shutters effect on their systems?
So yes, phase one shutters do contain are rolling shutters. However, the speed of the shutter and the design of the shutter mitigates the effect typically seen with a rolling shutter.
Perfect. And as for SimActive, we take in account the rolling shutters during our bundle process. So and then last question that we had is, can the EOs from one camera system be applied to another second data sets? Let's say if it's taken at the same time or with the better camera. So you can export, the final EOs from a single set image. But then if you want to derive it, if you want to attach it to a second set of images, you'll just have to make sure that the corresponding names and EOs information are available in your text file. I'm not sure if it was the proper questions, but yeah. So that was all for the question that we had today. So everyone, thank you for attending this online training session. I hope you have a great rest of afternoon, and hope to see you soon. Thank you. Bye-bye. And thank you, Don and Kevin, for your presentation today.
Thank you. My pleasure.
Thank you.